With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's begin with this question, and in this question it says that a uniform rigid rod of mass m length L is in mechanical equilibrium, constraint of horizontal and vertical rough surface. So we have to figure out which of the following option is going to correct. So first we have to calculate the torque around O and check whether this option is correct or not. So since the system is in mechanical equilibrium and if the forces are acting, this is the normal force N1 that is acting here. This is the normal force. Now this is the normal force N2 is acting. Mass will act downwards and the friction force to balance this normal will act into the opposite direction. So these are the forces that are acting. This is N1, this is N2, this is mg, and this is Fr. Now what we have to calculate is the torque around O. So since the system is in mechanical equilibrium, so horizontal forces will be equal. So N1 will be equal to mFr and N2 will be equal to mg. Now we have to calculate the torque at O due to normals. So at the point O, the distance of N1 is L sin theta if the length of this rod is L. So we take this as a negative N1L sin theta. If N1 will try to rotate into this direction, so this direction we have taken as negative, while N2 will try to rotate into this direction, so this direction will be taken as positive. That means here it is clockwise we have taken negative and anti-clockwise taken as positive. So it is N2L, and here the distance will be L cos theta, this one. So it is L cos theta, and this is equal to torque around O. Now we have to calculate N1 and N2 in the form of mg. So mg is already equal to N2, but we have to find out N1 is also in the form of mg. So what we do now, we will take the moment around this point. Let's say this is point P. So taking moment at P. So when we take moments at P, then N1 into L sin theta, and we have taken the direction of N1 is negative because it is rotating in clockwise direction, while mg force will balance the N1, so mg will rotate into anti-clockwise direction. So mg L by 2 cos theta will be equal to 0. So from here N1 L sin theta will be equal to mg L by 2 cos theta. So what we do now, we put this value into this equation and calculate the value of tau. So torque at O will be equal to, the value of N1 is mg L by 2 cos theta, but it was negative, and the value of N2 is mg, so this is mg L cos theta. So finally the value of torque along O will come out here as mg L by 2 into cos theta. So this is the value that we have obtained. So it already indicating that the option 1 is the right answer. Now moving around the option 2, it says that the friction force is producing zero torque here. So since the direction of friction force is this, and at the point O, it is passing through the point O. Since the line of action of friction force is along the O, so it will not produce any torque. So net torque produced by the friction force will be 0. So with this we can say net torque due to friction force is also equal to 0. Now talking about the third option, which says that the net torque produced by the normal reaction is equal to the net torque produced by the friction force at the center of mass. Center of mass is from where the mg is passing. So if you talk about the perpendicular distance of N1, this will be L by 2 sin theta, and the perpendicular distance of N2 will be L by 2 cos theta in this case. So torque will be, talking about torque, so torque around center of mass will be equal to N 2 into L by 2 cos theta minus N1 into L by 2 sin theta. Now N2 is mg, so this will be mg L by 2 cos theta, and we already calculated that the value of N1 L sin theta is mg L by 2 cos theta. So this will become, totally it become mg L by 4 cos theta. Mg L by 4 cos theta. So final value of torque at the center of mass due to two normals will be equal to mg L by 4 cos theta. Now we calculate the torque produced by the friction. So let's name this as tau F at the center of mass. So at the center of mass, so distance of frictional force from the center of mass will be L by 2 cos theta. So here Fr into L by 2 cos theta. While if we move toward the first equation, Fr is equal to N1. So this is tau Fc into Fr into, if you replace this will be N1 L by 2 cos theta. There is a correction here that this distance is not L by 2 cos theta, this is L by 2 sin theta. So yes, we have to replace this, that this is L by 2 sin theta here. So we have to correct that here, it is L by 2 sin theta and this is sin theta. So when we replace NL sin theta by mgl by 2, so the torque produced by frictional force is also equal to mgl by 4 cos theta. So this value and this value is equal. So we can say that torque produced at the center of mass by the two normals and the frictional force are equal. So with that, option 3 is also the right answer of this question. So this is about this question. Thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.